Okay, so the next thing we're going to do is we're going to find a missing value to make something into a perfect square trinomial. So skip these words for a second and just look down here so you can kind of see what I'm talking about. So I've got this trinomial x squared plus 20x plus c. Normally I have a number right here, right? And I don't. I have a c. That means on these types of problems, I'm going to want you to find the value of c that will make this into a perfect square trinomial. Okay? So there is a value of c that I could plug in here that would make this where I answered yes to all three of my questions as I was checking, right? So here is the process. You will want to copy down these three steps. This is a process that will always work. What's your question, Swayze?
Find the square root of 20. Would that be your...
No, but you're thinking along the right path, right? But 20 is not a perfect square, so we can't find the square root of 20. But this tells you what to do. The first thing to do is find half of b, right? So that's the coefficient of x. So on this problem, what's half of b? 10.
I can go ahead and tell you what the answer is.
Good, yeah, and several of you, I'm sure, already kind of figured out how to do this without my steps. Okay, then the step 2 is square the result of step 1. So that means square this. And what do I get when I... And then step 3 is plug that in for c, because that's c, right? That's all there is to it. Half of b squared equals c. Let's run through our checklist just to make sure we did do what we set out to do, which is make this into a perfect square trinomial. Is the first term a perfect square? X squared. Is that a perfect square? Yes, thank you, Bella. Is 100 a perfect square? Yes. If I took the square root of these, I'd have x and 10, so I'd get 10x. Is 20x 2 or negative 2 times 10x? It is. So we did. We succeeded. We made something that was a perfect square trinomial. And I'm not going to ask you to factor these, but if I did, you could, right? This would factor to be x, take the square root of that, take the plus from there, and the square root of 100 is 10 squared, right?
So what if this c ends up not being a perfect square?
It will. It will. Because remember, it's always going to be a perfect square because we're going to square something to get it, right? Does anybody need more time to copy down these three steps? Okay, great. Just let me know when you finish, please. You got it? I think Nathan's doing it. You got it? Okay, so let's work a couple. So these problems, there are problems exactly like these on the homework tonight. The first 4 problems. Just ask you to find this missing value. They look exactly like these look. So, what was the first step?
Find half of b.
Half of b. So half of negative 6 is
3.
negative 3, or 3. You can think of it either way because we're going to square it. So the sign doesn't really matter, right? It doesn't matter if I think of it as negative 3 or 3, because the next step is to square it, and if I think of it as negative 3, what's negative 3 squared? And if I had thought of it as positive 3, what's positive 3 squared? So it doesn't really matter, right? And then I substitute that value in for c, and I'm done. That's it.
This is easy.
That's the first 4 problems on the homework are like that. These are really easy. Now, sometimes, some of you, I'm guessing, have already looked ahead to number 2, and you realize number 2 is not quite as nice as number 1. Because what's half of 11? So let's keep it as a fraction, because that will actually be even easier to deal with than the decimal. So 11 divided by 2 just equals 11 over 2, right? And then we would square that. Remember, to square a fraction, you just square the top, square the bottom, right? Because what we're really doing here is 11 over 2 times 11 over 2. So we're multiplying 11 times 11 on top, 11 squared, and 2 times 2 on the bottom, 2 squared, right? So what's 11 squared on top? So what? 22? That's 11 plus 11. What's 11 times 11? 121. And then 2 squared on the bottom? 4. And then we plug that in for c. So we would have a squared plus 11a plus 121 over 4. Now, some of these you will have to deal with fractions on the homework, just to warn you. But it's not difficult. It's not difficult. If you're dividing an odd number by 2, the fraction is just that number over 2, right? There's nothing, you can't simplify. Okay. Questions about these?
No.
I got a couple more to work. Does anybody need more time on this side? Okay, just let me know when you got it out. You got it? Okay. Alright, so 2 more, and then we'll actually get into what I really have to show you, which is the completing the square. Okay, so half of b would be 4 squared. Nervous. Let's totally stop working in a second. Okay, and 4 squared is what?
Oh, 16.
What'd I say? Oh, there it is. Okay, and then I would plug 16 in for c. And I'm done. What's half of 18? 9. What's 9 squared?
81.
Yes, it's a 9.
G squared.
It does, it looks like a G.
Use the G.
This answer is actually wrong. Don't copy down this example. There's none like that on the homework. This is a more complicated example. This is from an old, from the way I used to teach this lesson, but I'm not giving you any like this.
Well, you
So
have to
don't
get rid of
copy
that
it.
9.
It's not. Say what?
When you have to get rid of the 9.
Yeah, you have to account for the fact that it's got a 9 here, a leading coefficient other than 1, and we're not working like that today, so it's just best not to write this down. Okay.
Yeah, you had me a little nervous when I seen that one.
Okay. Yeah, none like that on the homework.
I skipped that other one. I just get rid of a couple.
Okay, so now we're actually going to use it to solve an equation.
Oh my gosh. All this to get back to what we've been doing.
Yeah.
Be real.
Now this is where the rubber meets the road. This is where it gets a little tricky. So make sure you really copy down this example, okay, and ask me questions about the steps that don't make sense. This process only works if the leading coefficient is 1. And tonight on the homework and today in class, I will only give you problems where the leading coefficient is 1, like this one. Tomorrow we'll talk about how to fix it if the leading coefficient is not 1, so that you can work this, use this procedure on any type of quadratic trinomial. But we'll just stick with these for today. Okay, the very first step is to take whatever constant you've got here and move it to the other side. So my very first step would be to add 18 to both sides. That's the opposite of what we've normally been doing, because normally it's trying to make sure we have a 0, right? And with this method, we don't want this 0. We need to move this over. Okay, so x squared plus 8x equals 18. Okay, there I am. Now, I want to turn the left side of this problem into a perfect square trinomial. That's why it's called completing the square, because I'm going to add something to this side in order to make it a perfect square trinomial, and we just learned how to do that, right? I take half of b, which would be 4, and I square it, which gives me what?
16.
16. So that is the number that will complete this perfect square trinomial. So I've got 16. Now, I'm going to add that 16. So now this side is a perfect square trinomial.
And 18.
But if I add something to one side of an equation, the whole deal with equations is do unto one side what you do unto the other, right?
I hate
So if you add 16 to this side, that means on the other side, I've also got to add 16 so that I'm not changing the equation, right? So I've added the same thing to both sides, which means I haven't changed it at all. Now, this side I'm going to factor the way we just learned how to factor perfect square trinomials. So that means it breaks down into 1 parentheses squared. and I have the square root of x squared is x, the sign from the middle term is a plus, the square root of 16 is 4, and this parentheses is squared. And then over on the right hand side, those are like terms, so I put them together, and I get 34. Okay, now, what this has accomplished for me is it's taken the two x's I had, the x squared and the x. That was my problem with solving these the way we're used to, right? That's why I couldn't like start by adding 18 and then dividing by 8 or doing the normal things, just because it has those two x's. But now I've gotten it down to where there's just one x. So from here to the end, this will be like solving equations like we've done before, right? I need to get rid of the squared. How do I accomplish that? So I take the square root of this whole side and this whole side. Yes, I know my board is having issues. Let's see if I can fix it in a minute. So over here, the squared and the square root, they cancel out. That's what they do. And that means on this side, I'm left with just x plus 4. Now on the other side, I'm going to try and take the square root of 34. So why don't you take a second and see if you can take the square root of 34. Most of you probably already know. That's not going to work out. So this is one of those, like with the quadratic formula, where I'm going to need to write the answer two ways. Okay? So I can't simplify square root of 34. I do need to add the plus or minus in front of it. Because remember, when we're solving an equation, we take a square root. We have to account for the fact that there is a positive square root of 34 and a negative one, and I want us to consider both. That's why I put the plus or minus. I'm one step away from being done with this problem. Nope, x is still not by itself, right?
Add the 4 to the,
Subtract 4. And then I will have x equals negative 4 plus or minus the square root of 34. That is the answer. I need to separate it out into two, right, and then get the decimal for it. But this is it. This is the answer. That's the whole process. So I would have x equals negative 4 plus the square root of 34, and x equals negative 4 minus the square root of 34. That would be the first way to write my answer. And then the other way requires the calculator, right, where I get the decimal approximations for these. So let's see if we can get those. So y'all should check me on these, make sure I don't type anything in wrong, but I got 1.831 and x equals negative 9.831.
I've got one question.
Yes, sir.
Would you still put the negative 4 and plus square root of 34 over a 2?
No. That's a good question, because you're used to, when you see something like that, it's part of a fraction, it's got something on the bottom from the quadratic formula, but no. This doesn't, most of the time this doesn't end up like that. Now, I maintain that if I had used the quadratic formula, I would get these same answers, that it doesn't matter which way I solve it. And so I would like to try that really quickly. It'll be good practice for us to see if we do actually end up with these same answers. So let's plug into the quadratic formula up here and see what happens. So I would have negative b is 8, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so somebody evaluate that discriminant for me.
Which one?
Right here. Yep, that's what I'm getting to, 136. Okay, so they don't look the same. They don't look the same. But that's because you haven't learned how to simplify radicals yet, which we're going to do on Wednesday and Thursday. And we could make them look the same. But here's a surefire way to check. Punch the top in, so do negative 8 plus the square root of 136. Whoa. That's a 136. Hit enter and then hit divided by 2. And let's see if we get the same decimal. Because I'm saying that you should get 1.831.
You do.
You do, right? So this gives me the same answers that the quadratic formula does, right? All these things help me arrive at the same place. Are there other questions about this process? I'm going to work at least 3 more examples before I ask you to do any, but are there any questions that you can see right now?
You have to watch it work with the other ones.
Okay.
Still running.
Alright, so let's work a few more. Well, if I can get the board to work.
Hey, it worked.
Well, sort of.
Please don't get squeaky out.
Yeah, hopefully I won't have to. There we go. Okay. So, what's the first step? Who remembers the first step? Question? Yes. First step? Yes. Take the constant, move it to the other side. So subtract 8, and we get x squared minus 6x equals negative 8. Who remembers the next step?
Find C.
Find C, complete the square, right? Find the value of C that would make the left-hand side be a perfect square trinomial. And the way we do that is we take half of B and square it, and that's what? 9, right? So we end up with, this problem's getting to be real familiar because we've already seen it a couple times today, but we end up with x squared minus 6x plus 9 on this side. And the one thing you have to be careful with and not forget is, I added 9 to the left-hand side. I gotta add 9 to the other side too.
I'm gonna forget that.
Me too.
Practice will help you remember. Practice will help you remember, I promise.
You gotta factor the, yeah.
Good, so I'm going to factor the left-hand side and I'm going to combine like terms over here. So this is going to factor to be what? X minus 3 squared, and negative 8 plus 9 combines to be 1. Alright, we're getting there. Take the square root. That's the way I get rid of this squared. It's with the square root. And this side too. The squared and the square root cancel each other and leave me with just x minus 3. And then I can actually take the square root of 1, right? It's 1, but I cannot forget the plus or minus. Yes, sir?
I don't understand how you got x squared minus 6x plus 9 equals negative 8 plus 9.
Okay, so we from here we decided to complete the square, right? We were going to make this side into a perfect square trinomial like we did on the slides before, where we found that C that makes it work. And so we did that. We found half of B and squared it to get that number. And I added it to both sides. I can add whatever I want to an equation as long as I do it to both sides, right? And the reason I did it, normally I wouldn't do something like this. It's not obvious how it helps me solve the problem to add 9 to both sides. But what it does for me is it makes the left-hand side into a perfect square trinomial so that I can factor it down to this.
Okay, I got it.
Yes, ma'am?
Hang on. Why did you change the x minus 3 to x plus 3?
Because I made a mistake. That's a donut point. Thank you. Because I was going to get wrong answers. Thank you very much. That should be an x minus 3. Okay, and I'm one step away, and that one step is add 3. Then x will be by itself. X equals 3 plus or minus 1. So we can get the two answers real easy. One of them is 3 plus 1, which is what?
4.
And one of them is 3 minus 1, which is
2.
Look at this problem. If we had done it with factoring, we could have done it with factoring really easy. I need numbers that multiply to be positive 8 and add to be negative 6. Negative 4 and negative 2, right? So I would have x minus 2, x minus 4 equals 0. And if I set these equal to 0 and solve, this one gives me 2, and this one gives me 4, right? Same answers, no matter which way I work. The quadratic formula would give me 2 and 4.
I've got a question.
Yes.
If we get home and can't figure out one of these on Bellwether, can we just go back to the old one and get
No.
the answer? And you
No.
just,
And on the test, that's an excellent question. That's an excellent question because on the test, there will be a temptation to do whichever one you feel the most comfortable with all the time. But you can't do that. I'm going to check your scratch work on the test and make sure you're solving it the way I asked you to in the instructions. Otherwise, you won't get credit. Because sometimes you need to be... Factoring doesn't work all the time, right? If I have one of those really ugly answers, I can't do it this way. So I can't rely too heavily on that. Quadratic formula does work all the time. So does completing the square. They work all the time. But there are advantages to both of them. And so you need to know how to do both. That's a good question, that's right. Okay, step 1 on this is what?
Add 9.
Add 9. Move the constant to the other side. Alright, so I get x squared plus 4x equals 9. Then I want to complete the square. I got it broke down. Find C, right? Complete the square. Find that value that will make the left-hand side a perfect square trinomial. And the way I do that is I take half of this and square it. And that gives me 4. So I need to add 4 to both sides. X squared plus 4x plus 4 equals 9 plus 4.
I've got a question. Instead of another question. Okay.
Go ahead. It's fine.
Instead of waiting to combine the like terms on the 9 and the 4, can you go ahead and add them together
Sure, sure.
before you?
Absolutely. So I'm going to factor the left-hand side. It's going to factor down to 1 parentheses squared. The square root of x squared goes first. The sign from the middle term, so since it's a plus, I put a plus. And the square root of the third term equals 9 plus 4, which is 13. Now what? Square root. Square root cancels with the squared. And I end up with x plus 2 equals, I would try and take the square root of 13, I'd realize pretty quickly it's not a perfect square. So this is one of those where I'm going to have to write it 2 ways. What's the last step? Subtract 2. Now I have solved for x, and I'm ready to write my answers. So the first way would be x equals negative 2 plus the square root of 13, and x equals negative 2 minus the square root of 13. And then to get the other one, I need decimals. So I want you guys to give me the decimals.
I got 1.6055, but it actually be 106.
1.60.
1.606, I think.
Good. 1.606 if we round it correctly. And then let's see what the other one is.
Negative 3.7.
That's not what I got. Try again. Make sure you punch it in right. I got negative 5.606.
3.
You didn't get the negative 5 one? Oh, you didn't put a minus. It's negative 2 minus the square root of 13, right?
When I put in 13, it didn't get the 1.
Questions? All right, one more. Then it's your turn. All right, step 1. Move the constant to the other side. Step 2, complete the square. Find C. Take half of this, square it. So I end up with x squared minus 6x plus 9. Man, that guy just keeps showing up. Equals negative 7 plus 9. If I add it to one side, I've got to add it to the other. Then I'm going to factor this side, combine like terms on this side. So on this side I get x minus 3 squared, and on this side I get 2. Good. Then I'm going to take the square root of both sides. That's to get rid of my squared. These cancel, and I get x minus 3 equals plus or minus the square root of 2, since 2 is not a perfect square. And then I add 3 to both sides. X equals 3 plus or minus the square root of 2. That's the answer. I just need to write it out. So x equals 3 plus the square root of 2. X equals 3 minus the square root of 2. There's one way. And then the other way is my approximations.
I like that writing it 2 ways.
You don't like to write in 2 ways? Yeah, I hear you.
First one's 4.414 and 1.586.
1.586, good. So, for the 2 ways, it's mostly so you can practice getting the right thing in the calculator. It's funny, on those quadratic formula worksheets, I'm sure some of you saw, you got like the exact answer right, the one with the square roots, but then not the decimal answer right. That shows me that it's smart that I'm making you write it 2 ways, because that means you're having trouble taking this and getting the calculator to give you the right decimal. That's the main reason, right? It's just so that we get practice putting it in the calculator, because remember, the calculator is only as smart as its operator. So we have to make sure that we are smart enough to make it do what we want it to do. Okay, clock appointment again. solving these by completing the square. It says on your own again, but we're not doing that. We're over problem.